Okay, today we're going to keep plugging along, and we have lesson 10 called Tax and Tip. Please take a look at the learning goal, which is that we're going to understand and solve problems about sales tax and tips. So today's lesson is a really practical one. This is day to day, something that you encounter out when you're shopping, when you're eating, doing just about anything. And so we're going to look at some very practical examples today. Now, what I want to do with this first example is do the first part with you and then talk about just kind of take a step back for a second and talk about how this all ties in with those ideas of proportional relationships that we just keep coming back to. It's such an important idea and it ties through so much of the math that we're doing. So for the example today, it says we're shopping in two different cities. Different cities have different sales tax rates, and that is true in real life. Here are the sales tax charges on the same items in two different cities. Complete the tables. So let me demonstrate with city one. So if we look close, we have four different items and then an item with a variable representing the price. So it could be any item and any pricing for that. We're going to have a column here for the sales tax. These are both in dollars. Now, sales tax is that extra percentage that you pay on top of something that you're buying. So you purchase an item, it says on the shelf that the item, like let's say the paper towels cost $8, but you know when you get to the register, that's not what you actually pay for the item. You're paying the store $8, and then the city and the state take a little extra from each of those purchases that goes to the government. So that's always a percentage rate. So it's a part of what you're spending on the item. If we buy paper towels for $8 and we pay a sales tax of 48 cents, then of course when we check out, we have to pay for the $8 item and the sales tax. So these two numbers get added together, they get combined. If we look at the lamp, it's the same deal. But because the lamp costs more and we're paying the same percentage of the cost, so for each dollar we spend, we pay a percentage of that cost. The more dollars we spend on an item, the more we're going to pay in tax. So this is a higher tax on this $25 lamp because it costs more than the $8 paper towels, but we would still add them together to get our total. So we'd pay the $25 and the $1.50 in tax and pay a total of $26.50. Now, for the next two items, it doesn't tell us what the sales tax is, but again, it's going to be the same tax rate, the same percentage as the first two examples. We just have to figure out what that is. Now, this is the cool thing. It's a constant of proportionality. So between the price of the item and the sales tax is a constant of proportionality there. And it's going to be the same for all of these. So once we find it here, we'll be able to use it for these other examples. Now, it's been a little while since we've done that, but remember when we were really working on proportional relationships, we took that equation that y equals k times x and we rearranged it so that we could find k, our constant of proportionality. And if you remember, we would divide y by x to do that. Well, that's what we have here in our table. We're going to ignore this last column for now. We're going to look at this here as being y for the price of the item. I'm sorry, x for the price of the item, y for the sales tax. So if we divide 48 cents by 8, we get 0.06. And if we did the same here and divided $1.50 by 25, we would get the exact same answer. We would get 0.06. So that is our constant of proportionality. We multiply by the constant of proportionality, 0.06, and we're going to do it here, here, and here. And really for the variable as well. We're going to take our constant of proportionality times x. For $12, if we multiply 12 by 6 hundredths, 0.06, that is 72 cents. And for $1, it's 0.06. Now this one should have been able to be done without calculating because this is the unit rate. We know that the constant of proportionality comes from the unit rate. So of course, this $1 is going to show us the constant of proportionality as the Y value. Now what this means is that for every dollar you spend, you're paying 6 cents in tax. All right? So every dollar, every 25 of these dollars, you're paying 6 cents in tax, and that added up to a total of $1.50. And that would continue for any item, no matter its value. Now we'd have to add these together to get the total costs. And if we fill in the total costs, adding them together, we'd spend $1.06 for the pack of gum, and we'd pay $12.72 for the laundry soap. Now, there is a shortcut and a way to calculate the total cost altogether. Now, we could take X and we could add it to the 0.06x that we have here with our constant of proportionality. We could add those two together to get the total cost. We can also combine them because here we have 1x and here we have 6/100ths of an x. That combined is 1 and 6/100ths x. If we just kind of smash it all together, we need that 1x and that amount. And the question doesn't ask for the percentage, but I do want to talk about that because we have said that the word percent is saying per 100. Now, what we're really doing here is we're taking our unit rates. Remember, we said every dollar you spend, you pay 6 cents in tax. And now we're going to compare it per 100. So let me write that out a little differently. If we were paying 6 cents in tax for every $1 spent, now if we're looking at a percentage, we're looking at out of $100 spent, how much would we be paying in tax? We would be paying $6 in tax. Now, these two ratios are equivalent to each other. This is our unit rate for spending $1. We spend 6 cents in tax. If we spend $100, now is our percent, our per 100. Per $100 spent, 6 of it is going to be for taxes. So just to give you a little idea, if we were asked what is the percentage, the sales tax percentage in City 1, you wouldn't tell them the constant of proportionality, you would give it as a percentage. Per 100, we're paying 6%. So that would be the sales tax rate for City 1, 6%. All right, now go ahead and fill in City 2 just as I did using the different information. Okay, for the next example, we're shopping it in a third city now. So notice we have the same 4 items. We have the same 4 starting prices for those items, the price at the store, and now the sales tax is slightly different. So the first question asks us, what is the tax rate in this city? Well, to be perfectly honest, it is listed for us right here without any calculating. Remember, find the unit rate. We're comparing to $1 spent, 7 cents in sales tax. So that's 7 cents of every dollar is going to be the sales tax. If we're asked to find the tax rate, now let me write that out. So our constant of proportionality here, to go from the price to the sales tax, would be that 7 cents, 7/100ths. If I write that down, that's not the percentage until I compare it per 100. So what it's asking is if basically if we continued this and bought an item for $100, how much are we going to pay in sales tax? We're going to pay $7 in sales tax. So our percent is 7%. Now it says for the sales tax on the laundry soap, Kieran says it should be 84 cents. Lynn says it should be 87 cents. Do you agree with either of them? So we'll take our constant of proportionality, we'll take our sales tax, we'll multiply it by the cost of the laundry soap, which is $12. And when we do that, so I forgot a zero there. All right, when we do that, what we get is 0.876. Now that is a number that cannot be paid in a denomination. We need only two places to pay, just like our examples up here. So we'd have to round it. Now, for the most part, a store is not going to lose money on your sale, and they're not going to round down. But especially in this case, we can see that this is either 87 cents or it might round up to 88 cents. And looking here at this thousandths place, that's going to tell us to round up to 88 cents. So that item should cost should cost an extra 88 cents in sales tax. So Kieran is definitely wrong, but Lynn is also wrong because she rounded down, or she just got rid of this little extra amount because you can't pay it. Unfortunately, that's not the case, and most stores are going to round it up just to make sure they get everything that's owed to them. Let's continue. So we're dining at a restaurant. Jada has a meal in a restaurant. She adds up the prices listed on the menu for everything they ordered and gets a subtotal of $42, and that's always listed here on the receipt. Okay, so you can see the subtotal is when it adds up every item that you purchased. Now, the thing that's going to change that is going to be tax. So when a check comes, it says that they also need to pay $3.99 in sales tax. What percentage is the subtotal of the sales tax? Now, just like we were doing with the tables on the previous problems, we need to find that constant of proportionality. So we're looking for what can we multiply by 42 to get $3.99, that being our sales tax amount. We're going to reverse that equation, we're going to rearrange it, and we're going to divide our y by our x value. We're going to divide our sales tax by the subtotal. So to get our y, to get our k equals y divided by x, we're going to divide our sales tax by our subtotal. And $3.99 divided by 42 is, one second. There we go, 0.095. All right, now remember, this isn't a percentage yet, and our sales tax needs to be as a percentage. This is $1. So you spend $1 and you pay just over 9 cents, 9.5 cents. If we look at spending per $100, then we're going to be spending $9.50, 9.5%. That would be our sales tax here. For the second one, it says after tax, the total is $45.99. What percentage of the subtotal is the total? All right, let's look at what we're comparing, because we're going to make a ratio just like we did here where we compared the sales tax to the subtotal. Now we're comparing what percentage of the subtotal is the total. So we take our total, let's use a different color, our total, $45.99, divided by our subtotal, $42. And when we do that, you get 1.095. 5. Now, these look very similar to each other. This just has that extra 1 there, but the decimal is the same. So it's still containing that 9.5%, but now we have a whole amount of something. We're paying for the whole subtotal and the 9.5% sales tax. So as a percentage, we're paying for 109.5% of the subtotal. We're paying for all the subtotal and that extra tax. Okay, finally, they actually paid $52.99. The additional $7 is a tip for the server. What percentage, here again, we're answering a very similar question, what percentage of the subtotal is the tip? Okay, we need to divide. So we'll take the tip, $7, divided again by the subtotal, and 7 divided by 42 equals 0.16 repeating. So to answer that question, to get what percentage, we need to compare per 100. So we're going to look at this as being 16, and we're going to have to either round or we'll have to show it as a repeating percentage, which is okay. Remember, it's 0.6, and these 6s are just going to continue forever, so we're going to represent that with a repeating symbol. And this is our percentage for the tip. The tip is 16.6 repeating percent of the subtotal of the bill, the $42. All right. Now we're getting close to the end here, and we have just a continuation of the situation that we did previously. It says the tax rate at this restaurant is 9.5%, which is what we just found on the previous example. So we're talking about the same restaurant here. We're looking at different checks for different orders here at the restaurant. And the question 4 says another person's subtotal here on the receipt is $24.95. How much will their sales tax be? Okay, well, we're told the tax rate. We found that in the last situation. So we need to find 9.5% of the subtotal. Remember, here we're going to, well, in the last example, we did a lot of division, and we were dividing to find that percentage in each of these questions. And that percentage was that constant of proportionality that we were talking about. Now we know the constant of proportionality is 9.5% or 0.095, and we need to calculate how much is spent in tax. So this is where we're going to take the subtotal, multiply by the constant of proportionality, 9.5%, to get our total, or I'm sorry, to get our sales tax. So let's do that. If we take and multiply this, remember we're not going to push 9.5 in our calculator. This is 9.5%. So we need to take 24.95 times 0.095. That'll tell us that the sales tax is going to be $2.37. Part 5 says some other person's sales tax is $1.61. How much was their subtotal? So if you notice, we're going to be going in the other direction. We're going to go from the sales tax back to the subtotal to find what they're asking us in that question. And anytime we reversed in that proportional relationship in that table, we had to do the opposite. So we're going to, instead of multiplying by 9.5%, we're going to divide by 9.5%. So we'll take the $1.61 that was spent in sales tax. We're going to divide it by our percentage. I don't want to put in 9.5 though. I want that. And when we divide that out, what you get is $16.95. That would have been their subtotal. And that makes sense that they paid less in sales tax than the previous person. So their bill should cost less than the previous person. So do a couple of those checks to make sure your answer is reasonable. All right, I do want you to take a look at this last question, see if you can answer it. I'll be posting the correct answers in the notes. So please try it first, see if you can solve it, and then check with your answers. And any questions that you have on the lesson today or on your practice, please just reach out to me on Zoom and we will get it figured out. Everybody have a great day.